Hello, thank you for coming to my talk. I'm Yulu. The name of the talk is PlueckerNet, Learn to Register 3D Line Reconstructions. We first look at the problem definition. We study the problem of aligning two partially overlapping line reconstructions in Euclidean space. One is the source 3D line reconstructions, and the other is the target. They are partially overlapping. To align the two reconstructions, we estimate a 6 degree of freedom transformation, the relative rotation and relative translation between them. Aligning the two 3D line reconstructions have some applications. For example, in the visual localization application, we can have a query 3D line reconstructions from a RGB sensing module. We also have a pre-stored 3D line map. Given the query and the pre-stored 3D line map, we can estimate the 6 degree of freedom camera pose, rotation, and the translation of the query by aligning the query to the database. To solve this problem, existing works assume long line-to-line matches. Instead, in this work, we do not have this limitation, and we jointly estimate line-to-line matches and solve the relative rotation and translation. Given the source and the target line reconstructions, we use their Pluck coordinates as inputs to a subspace coding module to extract high-dimensional line-wise features. And then we improve the discriminativeness of features via a feature embedding module. Given line-wise features, they are fed to a global feature matching module to estimate line-to-line matches. With line matches, we estimate the relative rotation and translation with a two-line minimum solver in a RunSec framework. The subspace coding module used a two-branch neural network to extract features from directions and moments independently, and then finally concat them. Given line-wise high-dimensional features, the feature embedding module uses self-attention and cross-attention blocks to improve the discriminativeness of line features. The output of this feature embedding module is line-wise feature. Given line-wise features, one from the source and one from the target, we use a global matching module to establish a prioritized line matching list in an optimal transport framework. We compare our method with two baselines on the structure 3D and semantic 3D datasets. Our estimations are more accurate in terms of the rotation and translation errors. We further use a real-world application to show the effectiveness of our method. The application is line-wise visual odometry. Given consecutive images and depths, we extract 3D lines for each frame, and we then estimate the relative poses for consecutive images. We use the recourse of rotation and translation to compare our method with the baseline. For the recourse, the higher the better. The figures show that we achieve better results. In summary, we propose a learning-based method to align 3D line reconstructions. The paper and the code can be obtained via the links. Thank you very much.